This is Algebra 1, Term 4, Lesson 1, Discovering Quadratics. We'll start with a classic Desmos activity, Will It Hit the Hoop? And then we will explore examples of parabolas and non-parabolas, examples of quadratics and non-quadratics, and we'll finish it up with a 3-act task, Record Flip. Let's get started in Desmos. This is one of the original, I think, Desmos activities. It's been around forever, and it's awesome. It has lots of slides, and a lot of these just go quickly because kids are predicting, so don't let that intimidate you, but this will take the bulk of your time. I do have this scheduled for 1 to 2 days, but I'd say probably a full 2 days might be good for this lesson. Let's start with the first screen. So this is where the kids are first introduced to a nonlinear application that's not exponential, and they can make these points line up pretty good. But it's not always going to work out that way in the real world. So this assignment is giving kids the need for a nonlinear model other than exponential. So lines are all wrong here, and they're discussing why, and then they're going to show an example of a line and a parabola. And so we're basically going to look at a basketball as it's being thrown, and you might throw out there that everything thrown upward is going to follow a parabolic path. I didn't really say that explicitly anywhere, but you could mention it if you want. They are going to make predictions. So at this point, you need to be sure you are pacing your kids, because later on there's a video that shows whether these go in or not. So if you have not paced your kids, some of the kids are going to figure that out, and they'll just go get all the answers, and they won't even make a prediction. So they're going to guess just by looking at the shape here, is this going to go in or is it going to miss? And then they're going to predict here, is this one going to go in or is it going to miss? They will play the video so they can see the path and then make a decision. They will do it again, and they will do it again. So you'll notice each of these videos is 1 second, so they can go through these predictions pretty quickly as long as they're remaining on task. All right, here's shot 5, same thing, and shot 6. And you'll notice they're all slightly different. And there's also some things to consider, like the backboard. If it hits the backboard, is it going to go in? Now here we have a parabola. So we can move this around and try to make it hit the shape. And this is shot 1. So initially they made a guess just by eyeballing it. Now they're going to make a guess using a parabola to help them. So another guess. Again, I would pace your kids, and I'd have them all on this screen maybe at the same time as they work on these. Same here. You will move these around. They can move both of these so they can get this to fit that as best they can, and then decide, will it go in or out based on the parabola. So they're going to do all the shots again, but this time with parabolas. Now this should take a little longer than a second, because the video, you're just watching it and making a guess. So they will have to do a little bit of work, but not too long. So this is going to go pretty quickly. And then at this point, they should be up through 18. So it would be good to pace them through 18 till everybody gets caught up. Then the students are going to answer this question. Did your prediction before the parabolas, did you think those were more accurate, or do you have more confidence in those, or the ones with the parabolas? Hopefully the parabolas helped. At least that's the point. Now here's where the answers are. So if you have not paced them to slide 18, this is what I was talking about. They're just going to click this and watch and see if it goes in. I'm not going to play that because I don't want to spoil the fun. There's shot 2. They will show whether it goes in or not on all these. So, all right, and then this is going to show a graph of the results. The green points would be your scores, and the classes scores. The parabolas. So you have 2 different graphs here, one for your predictions and one for your parabolas, and how did you do? So hopefully the parabolas helped and they did better, but we'll see. Then they're going to do an extension. These extensions you may want to wait on since we are going to be doing other things. This is slide 27. So you decide if you want to go over it, but how tall is the shooter? If you use these grid lines, how tall would that shooter be? And then once you put in the coordinates for the basket, it's going to generate an equation and put it here. And they're going to tell you the coordinates in the equation. What is that reference? Well, your kids probably should already know something about what these numbers are doing. So you could come back to this if you want to, because we're going to actually use a little activity in a minute where they use the values of a, h, and k to approximate the graph of a quadratic that models something similar to this. So these extensions, leave them there. Some of your kids may want to do them that are kind of bored and waiting on other kids to finish. So go ahead and leave those in there. But let's go ahead and go back to our slides. So what I'm giving them here are examples of parabolas. The parabolas are on the left if they hadn't figured that out, and the non-parabolas are on the right. So all of these graphs are curves. So not just any curve is a parabola. There's specific characteristics with a parabola. We're not getting into the definition at all here, and they don't need to know it, honestly, but they do need to be able to recognize when they're seeing something that's parabolic. Now this one looks super parabolic to me, but it's not actually a half an ellipse. So if you're wondering why that one's not included, that one is half of an ellipse. Parabolas can go sideways, although in algebra we don't really make our parabolas go sideways, but they can go that way. But see how this is kind of flat? And this is definitely like a semicircle. This is actually part of a hyperbola. They don't need to know any of that vocabulary, but what I want them to do is look closely and see if they can point out a few differences between the parabolas and the non-parabolas. And then we have quadratics. These are quadratics, and these are not quadratics. Now, two of these are parabolas. This one is a parabola, and this one's a parabola. None of the others are parabolas, but two of these are parabolas, but they're not quadratics. And so you don't have to tell them that, but they need to try to see if they can figure out what makes these quadratic and these not. They might also go back over here and notice all of these are here except one. One of these is missing. Which one got taken out? And so let them talk about that. I've got some guiding questions down in their notes. All right, the next thing they're going to do is analyze some data. So they're going to click on this link, and it's going to take them to a Desmos graph, and they have the data here in a table and in a graph, and they need to describe some things they're noticing. So they may notice some patterns in these numbers over here. They may notice them here. If they want to click on the graph, they can actually see the patterns. So they should just say a few things about what they're seeing, and they should type that here. What do you notice? What do you wonder? And then I do ask for a screenshot. So what they can do is take a screenshot of that Desmos graph and put it here, and then maybe add a few text boxes over that graph to point to things they're noticing. They can put their data in there too, their table, and talk about some things they may notice in their data. So just encourage lots of conversation about that data and about that graph. We're looking for symmetry. They may not use that word, but you might use that word when you reply back to some of their comments. All right, once that's done, we have two more formal analysis here of two quadratic functions. I'm asking them for the intercepts. I want the vertex. We've discussed vertex before. We had that on our absolute value function. And then here it gets a little interesting. Over what interval of x is the graph increasing? Well, they've done piecewise functions, so they've kind of had these types of instructions before, but they've not done it on a curved graph like a parabola before. So let's see how that works. And then what is the equation for the axis or axis of symmetry? And that is the dashed orange line. So that would be here. They can, of course, use Desmos to try to recreate that line if they need to do that to remember what that looks like. And then I do have some guided questions in their notes. So let's take a look at those. This question is, why are there two x-intercepts but only one y-intercept. So let's see if they can talk about that. You may discuss it as a whole class once the students have come up with some answers for that question. Here's another quadratic function, exact same questions. What are the intercepts, vertex, where is this function increasing, over what interval of x, and what is the equation for the axis, or axis of symmetry? And then the question in their notes this time is the slope of this graph constant? Explain your thinking. And then we're going to finish this up with a real fun application. You're going to show them a video, and this will be Act 1, and then they will work in their teams to answer the question, and I'll show you that in a moment. So let's go to the website. Okay, so this is When Math Happens, and I've given you a link to this activity in your teacher guide and in your teacher slides. So let's go ahead and look at this first video, Record Flip. Okay, so that is a real exciting video. So the question is, will he make the jump and take a guess? So that was on your first slide. So here's some other questions. What information might be useful, and write down some questions. Now they've given you another activity in Desmos, so I've kind of saved you the trouble of making another or doing another activity in the same class period. And I've just given you a link out to the graph, and they're going to use a parabola to see if that parabola would fit that model, and then decide if he will make the jump. So let's take a look at the Desmos graph. All right, so they have the bicyclist going through the air here, and there is a parabola, and this can be moved around. They can grab the point to move the H and the K where they want, but for the A, they're going to have to physically move it, and I'll give you a hint. They're probably going to want to type something, because if they just slide it, they'll probably never get it to fit very well. So suggest, if they're struggling, to just go ahead and highlight the number for A and type something to make it do what they want. And then once they get it as close as they can, then they need to answer the question as a team. Will he make this jump? Will he make it to the other side safely? What do you think? So that's going to be their final exploration for this lesson. So the last thing I did is ask them a few questions to maybe extend this. What else would be helpful to know? Is this a symmetric graph? They may have trouble. I did have a little trouble trying to get it to line up very well. So talk about that as well. Were you able to make that parabola fit? So have those conversations. The more talking they're doing and the more they're making sense of it, talking about it, the better. So encourage that. So that concludes our Discovering Quadratics lesson. Next time, we'll start looking a little bit closer at those equations for quadratics. Y'all have a great day.